Welcome to a brand new unit of APCSA. In this unit, we are going to cover the next big topic, which is a 2D array. We've seen arrays before a bunch of times in this class, and we know that an array is something where I can store basically a list of things. Each one has an index. We know that in an array, I can store actually whatever I want. I can make an array of ints, I can make an array of booleans, array of strings, I can make an array of govals, of grects, I can make an array of hotel televisions. So it's safe to assume that, am I allowed to make an array of arrays? Yeah, I totally am. And that's what we're going to learn about in this unit, is an array of arrays, or a 2D array. This is the picture that I want you to have in your head when you think of a 2D array. A 2D array is an array of arrays. Now, if we look at this, we have this black outer array, and what's in each box of this black outer array is one of these red inner arrays. So again, an array where every single box holds an array. Now, the thing that gets tricky about this unit is the idea of rows and columns. So let's be really specific about this. Rows are horizontal. So this is row 0, this is row 1, this is row 2, and in total this has 5 rows. The way that I figure out the number of rows is it's the length of the outer array. Columns, on the other hand, are the verticals. So this is column 0, this is column 1, this is column 2, and this is column 3. In total, there are 4 columns. The number of columns is the length of one of the inner arrays. That's going to be really important later on when we start coding this. Now, this is the picture I want you to have in your head for a 2D array, the array of arrays. Oftentimes, though, we'll really just think of it as a grid like this. This representation actually makes it a lot easier for us to think about what this actually is. The indexes are exactly the same as what we had before, so these two pictures are completely equivalent. Oftentimes we'll kind of draw 2D arrays as grids like this, but again, the array of arrays is the picture that I want you to have in your head. We're going to keep this picture up as we start coding because it can be useful. So I'll have it come back up whenever it's kind of useful to reference this image at any point. Now, what we're going to start with is the one aptly called example. So let's open up example. There's actually nothing in here to start. So let's think about, how do we actually make a 2D array? Well, how do we make a 1D array? It's been a little bit, so let's make sure we remember how to do that. If I wanted to make a 1D array of ints called nums, I could do int bracket bracket nums equals new int. Let's say I wanted it to be 5 long, I can do bracket 5. And this would be an array of ints 5 long. I'd have to fill it in. If I wanted to fill this in with numbers, I'd probably just do a for loop through nums and set every spot to be some number, maybe a random number. Now, if I want to do a 2D array, the way that I make an array is the type that goes in the box goes first, and then the brackets tell me it's an array. Well, when I think about my 2D array, as you can see here, remember what's in every single box is an array. So weirdly, this is the type that's in every box, and then the brackets tell me it's an array. And same thing here. I have to actually now give it 2 dimensions because I care about rows and columns. So this is a 2D array that's 5 rows and 4 columns, just like the one that we have in our drawing. And now we just said to fill in a 1D array, I would need to do 1 for loop through that array. But to fill in a 2D array, now I have 2 dimensions. I actually need 2 for loops. Whenever we've done 2 for loops in the past, the nested for loops, we've used I and J. And this time I'm actually not going to use I and J because, again, now we're dealing in the world of 2D arrays, which deals with rows and columns. So I'm actually going to use R and C for this. So let's do this. For int R equals 0, R is less than, what am I going to put here? Is nums something. The question is, how do I get how many rows there are? If you remember when we were talking with the image, we said the number of rows is the same as the length of the outer array. The outer array is the black one on my picture. And since that's the outer array, I should just be able to do nums.length. That would get the length of the outside array, R++. And then for int C for column equals 0, C is less than Now, what do I do here? How do I get how many columns there are? Well, the number of columns is actually the same as the length of one of the inner arrays. How do I get an inner array? Well, if I do nums bracket anything, doesn't that actually give me back an array? Because what's in that spot is one of the inner arrays. So I can just do nums bracket 0 dot length and then C++. And then for now, let's just go ahead and set this to be a random number. So I'm going to say nums, before we would do this as nums bracket I, but again, now I have rows and columns. So I'm going to do nums bracket R bracket C equals, and let's do int math.random times 10. That's going to be a random number between 0 and 9, including 0 and 9. Cool. We've made our first 2D array. Awesome. Now, let's write a little piece of code to, again, practice using 2D arrays. Let's go ahead and count up how many 3s are in this 2D array. I'm setting this to be a random number, so hypothetically, maybe I should get at least a few 3s. To do that, let's say we were doing that for a one-dimensional array. The problem was count up the number of 3s. Feels like a very coding back kind of problem. If I wanted to count up the number of 3s, I would need a counter. I'd need to loop through that array, and my counter would go up when I see something that's a 3. This is going to work exactly the same way with a 2D array, except now to loop through a 2D array, I need 2 for loops, my R for loop and my C for loop. So let's do this. Int counter equals 0, and then let's do our RC for loop. For int R equals 0, R is less than nums.length, the length of the outer array, R++, and for int C equals 0, C is less than nums bracket 0 is one of the inner arrays, and the number of columns is the length of that. C++. Oops. And what am I going to do? If where I'm at is a 3, then my counter should go up. And how do I access something from an array is nums bracket R bracket C, sorry, from a 2D array. If that's 3, then I can do counter ++. And let's go ahead down here and let's just print line. There are counter 3s. And let's go ahead, let's see how many 3s I have. So I'm going to compile this. Let's actually move it over here. And let's go ahead and run my example. And look, I get 2 3s. Very exciting. Now, isn't there a chance, because I'm doing this randomly, that I could actually get 0 3s for one of them? And that would just be so sad, right? It'd be so depressing to get 0 3s. So let's actually rig this so that we have at least a few 3s. In particular, let's make it so that we automatically, right off the bat, have 4 3s. And those 4 3s are going to go in actually each of the 4 corners of my 2D array. I'm going to have this picture ready to go as we're looking at this because I think it's useful in figuring out the idea of the 4 corners. So the first one is the easiest, is kind of the top left corner here. What's the row and column for that is 0, 0, and it's always going to be that. So we can do nums bracket 0 equals 3. Awesome. Let's think about now the top right corner. So over here, the row is still 0, so I can do nums bracket 0, but what's the column? Isn't it actually whatever the last column is? In this case, it's 3 because the last column is column 3. We know I could just do bracket 3 because I know that this 2D array is actually the same size as the one that I created in here. But of course, if we wanted to get the last thing in an array, wouldn't that actually be nums.length minus 1? So if I want to get the last column, isn't it actually nums bracket 0 length, which is the length of the inner array? That would be 4 minus 1. And then we'll set that to 3. So see what I did? I grabbed the last column. This is the index of the last column. Let's think about the bottom left. Now the column is 0, but the row is the last row. So I'm going to do nums bracket nums.length minus 1, right? Nums.length is the number of rows, minus 1 is the last row. bracket 0 equals 3. And one last one, nums bracket. Now the bottom right is the last row and the last column. So I'm going to do nums.length minus 1, nums bracket 0, oops, dot length minus 1 equals 3. And now if I compile this and I go ahead and I run it, I should now get a number that's at least 4 3s. So that's a little bit better than before. Let's do one more thing here. It would be really nice if I could actually verify that that's the right number by printing out my 2D array. Now, it would be really nice if I could just do print line nums, but unfortunately that's just not how Java works. This will print out some kind of crazy number. So what I really want to do is kind of loop through and individually print out each number. And of course, to loop through, I need to do the same for loop I've been doing the entire time. So let's do for int r equals 0, r is less than nums.length, r plus plus, and for int c equals 0, c is less than nums bracket 0 dot length, c plus plus. And what am I going to do here? Let's print nums rc plus a space so that we can kind of separate them out. Remember, the difference between print and print line is that print will actually print it all on the same line, which is what I want. I want the entire row on the same line, right? But once I've printed an entire row, which is what this C for loop does, don't I actually want to go on to the next line after this? So I'll actually just do print line, open, close. And if we go ahead and compile this and run it, look, there we go. There's my whole 2D array. Let's make sure I'm correct. 8 3s, 1, 2, 3, 4, 5, 6, 7, 8. So I am actually good to go. Now, I'm going to go off on a bit of a tangent for a second here, but I promise it's actually worthwhile. If I asked you what the world's largest cola beverage is, the most popular one, you'd probably say Coca-Cola or Coke. That's correct. Coke holds most of the market share of cola beverages. By the way, cola is a flavor. I don't know if you knew that, but a cola beverage is actually the particular flavor that Coke has. The company with the second largest share is actually Pepsi. Pepsi Cola is the second most popular cola beverage. And we're not including things like Diet Coke or Coke Zero or stuff like that. Big question of what's actually the third most popular, or what are the other contenders? There's some random like Safeway brands. I think Trader Joe's might have a cola. So there's some kind of interesting stuff there. Maybe Whole Foods has one. But there's actually another soda company called Royal Crown. And they make a soda called RC Cola. You might not have had it before. It's a little popular, I think, in like Canada or something like that. This is actually what RC Cola looks like. They have these actually kind of pretty light blue cans. And it tastes like a cola beverage. It doesn't taste all that different from Coke. Now, why do I actually bring this up? What's the deal with RC Cola? Well, if you look at our for loop here, we've always written this for loop where the R for loop comes first and the C for loop comes second. That's one of those things that can be kind of hard to remember. So instead of having to remember that just based off of nothing, we're going to call this for loop our RC Cola for loop. And if you just remember RC Cola, you'll actually never forget that the for loop through the rows comes first and the for loop through the columns comes second. So again, this kind of standard form of our for loop is going to be our RC Cola for loop. One last thing before we stop this video is I want to talk about how this actually prints out. And we've kind of seen this here with how we've printed out the numbers. But when I do my RC Cola for loop, R always starts at 0. So I start on this first row here. And what am I doing while the row is 0? I'm actually looping through all the columns. So the first thing I do is R is 0 and C is 0, and I print this one out. Then C should increase by 1. I have R is 0, C is 1. I print this one out. Then this one, then this one. Once I've gotten through all of the columns in the first row, my row increases. I go back to the beginning. So I print this one, this one, this one, this one. You can see actually the order is almost like we're reading a book, right? We go left to right, top to bottom. And this is always going to be the order that we print out or pretty much always do things with 2D arrays, unless there's some particular reason why we need to kind of loop through in a different order. All right, this is our first introduction to 2D arrays. Hopefully this makes sense and doesn't feel too crazy. We're going to see a cool example of using 2D arrays in the next video. Then we're going to do an AP problem after that.